My dear learner, today we are going to solve few problems from exercise 5.1. In the last video, I already discussed about the basic concept of arithmetic progressions, the unit terms of AP, that is an is equal to a plus n minus 1 into d, and also I derived this formula. How you derive this formula, I think you understood, and few example also I solved in the last video. Today I select two problem from this chapter, this exercise 5.1. So let us see question number 2 Roman 5 from exercise 5.1. The question is that write the first four terms of the AP where A is 1.25 and the common difference D is equal to minus 0.25. From this, we need to find first four terms of the AP, arithmetic progression. So let us come to the solutions. You see, here the first term is given. First term you already symbolize as A, so you may write A1 also, no problem. A1 or A, same things. A1 is minus 1.25 and the common difference already given, that is D is equal to minus 0.25. Since the first term is given, then you have to find another three terms. So including the first term, we need to find another three terms. Then you get four terms of the AP. So here the second term A2 can be found A1 plus D. In the last video also I discussing how to find the next term. So if you add the common difference of the preceding term, then you get the next term. So A2 is equal to A1 plus D. So in this way, if you put the value A1 and D, then minus 1.25 plus minus 0.25, then if you simplify these two, then it will come to minus 1.5. In this way, we can find the second term A2. In this way, the third term now. Third term A3 is equal to A2 plus D. So if you add the common difference with the second term, you get the third term. So in this way, you get the third term. So third term, already you find the second term. So second term is minus 1.5 and plus the common difference is minus 0.25. So by simplifying this two, we get minus 1.75. Then we come to the four terms of the AP. In the same way that you can find the fourth term, A4 is equal to A4 plus D, if A3 plus T. So A3 here already find minus 1.75 plus D is minus 0.25. So it will come to minus 2. So finally, we got the three terms A1, A2, A3 and A4. Therefore, the first four terms of the AP are minus 1.25, minus 1.5, minus 1.75 and 2. So this is the solution of question number 2 Roman 5. Then we come to another problems from this same exercise 5.1, that is number 4 from exercise 5.1. Let's see the question. Question is given here. Which of the followings are AP? If they form an AP, find the common difference D and write three more terms. And Numbers are given here. Number 4, Roman 12. Question number 4, Roman 12. So numbers are given here. Root 2, this is the first term. Root 8, this is the second term. Root 18, the third term. Root 32, the third term. Fourth term, sorry, 4 terms. So the first 4 terms are given, and you need to find next 3 more time. So let us come to the solution of this particular problems. Here the first term a is already given, that is root 2. Second term a2 also given root 8. Third term a3 is given root 18. The fourth term a4 is given root 32. If you see the given numbers, all the numbers are in purely radical form. I think all of you know about the purely radical form. So if any numbers bearing the radical sign root, square root, cube root, fourth root, then you call it a radical number. So they are purely radical because no number is outside, all number are inside the radical sign, they are purely radical number. So you know, purely radical numbers also can be convert into mixed radicals. If possible, let us try to convert into mixed radicals. So for our convenience, if you convert them into mixed radicals, it is easy to calculate. Easy to calculate means easy to find the differences between the consecutive term from the given terms. So a is here root 2, a2 is root 8, second term. So how you convert to mixed radicals, purely radicals to mixed radicals? So to convert into mixed radicals, first of all, you have to factorize. Factorize means prime factorize. So if you factorize 8, it can be 2 into 2 into 2, and you see here few numbers come in the perfect square form. So you can find the square root of the perfect square number. So in this way, root 8 can be converted to 2 root 2. 2 is come out. I think you understood how it convert to mixed radical. Then you come to the third term. Third term is root 18, and root 18 can be prime factorized as you see in the screen. Root 18 can be 2 into 3 into 3. So 3 come in double 2 times, so 3 is, can be expressed as square. So if you convert into mixed radical, then come to 3 root 2. In this way, root 18 can be converted 3 root 2. Then we come to the fourth term. Fourth term, a4 is root 32. If you factorize root 32, then 32 can be 2 into 2 into 2 into 2 into 2. That means in power notation, it will be 2 to the power 5. Or if you can in the perfect square form, 2 square into 2 square into 2. So then if you convert it to mixed radical, then it will come to 4 root 2. So root 32 can be converted into 4 root 2. That is the mixed radicals of root 32. Now we come to find the difference between the consecutive terms, because here in the problems we need to check, we need to verify whether the numbers form an AP or not. So for this, let us find the difference between the consecutive term. First we start from second term minus first term, a2 minus a. So you see in the screen, a2 minus a, you substitute the value of a2 and a, 2 root 2 minus root 2, then come to root 2, and difference between the third term and second term, that is a3 minus a2. So a3 is here 3 root 2 and a2 is 2 root 2, then come to root 2. You will simply easily you can find it is root 2. And the difference between the fourth term and third term, that is a4 minus a3. So if you put the value, whatever you find here in the mixed radical, you just put this mixed radical form, 4 root 2 minus 3 root 2, then it come to root 2. So here you see difference between the consecutive numbers are same. That means the numbers have a common difference. So since the given list of number has a common difference, therefore they are in AP, where the common difference D is here root 2, and already you know the first term A is root 2. Both are same, no? Don't be confused. Sometimes it may be same also. So common difference root 2, and the first term A is also root 2. So first part we have done that this given list of numbers are in AP. So if they are AP, then we have to find another 3 terms. You have to find another 3 terms from this AP. Since we already verified the given list of numbers are from AP, so we can find now next 3 terms. So already first, second, third, and fourth term is given. Then the next 3 term will be a 5th term, 6th term, and 7th term. So if you follow up the definition of arithmetic progression, if you add the constant number, that is the common difference in the preceding term, you get the next term. So A5 can be determined by adding the common difference D with the preceding term A4. So A5 equal to A4 plus D. Since we already find the fourth term, so fourth term is 4 root 2 and the common difference root 2. By simplifying, we got 5 root 2. 4 root 2 plus root 2 equal to 5 root 2. Since the given numbers are in the form of purely radicals, so since 5 root 2 is a mixed radical, if you want, then you convert into a purely radical number also, because 5 is outside, no? If you bring in the inside the radical sign, it becomes square. So 5 becomes 5 square. So if you bring 5 inside the radical, then it will be what? Root over 2 into 5 square. 5 square means 5 square means 5 into 5, that is 50, 25. So 25 into 2 is 50. In this way, 5 root 2 can be converted to root 50. Then we come to the sixth term. Sixth term is in this same way. We can find the sixth term. A6 is equal to A5 plus D. So A5 already find, that is root 50. But don't put root 50. For your convenience, you put mixed radical form. That is 5 root 2. So A5 is 5 root 2 and D is root 2. So in this way, you can simplify to 6 root 2. And 6 root 2 is a mixed radical form. So if you convert into a pure radical form, then 6 is outside the radical. If you bring inside the radical sign, then it will be 6 squared. So root over 2 into 6 square. So 6 square means 6 into 6, that is 36. 36 into 2 is 72. In this way, 6 root 2 can be converted root 72. So now it convert to pure radical form. Now come to the seventh term, that is A7. A7 is A6 plus D. In the same way, you can find the seventh term. A7 is equal to A6 plus D. Since you already found that sixth term is 6 root 2, so you put 6 root 2, don't put root 72, otherwise you may fall difficulties to find the calculation. So that is why you put the mixed radical form 6 root 2. So 6 root 2 plus root 2, then it comes to 7 root 2, and 7 root 2 is a mixed radical number. So if you convert into pure radical form, then it will come to root over 98. I think understood. 7 inside the radical will be 7 square, no? 2 into 7 square, so 7 square is 7 into 7 is 49. 49 into 2 is 98. In this way, 7 root 2 can be converted to root over 98, root 98. So in this way, we can find the next 3 term. So here, therefore, the required 3 more terms are root 50, root 72, root 98. So this is the solution of the next problems. So I think you understood. There are so many problems in this exercise, but it is very difficult to solve all the problems through online class. to the online class, because there is very limited time and space also very limited. So that is why I select only few problems which help you to solve the remaining problem of this exercise 5.1. And 5.1 is the easy chapter, easy exercise. I think if you try, easily you can manage. I think you can easily manage. So for you, I select few problem from this exercise, the homework. If you solve from your own, and you feel very confident, and I think you can manage the problems. So let's see the screen. So the homeworks from this exercise 5.1s are: number 1 Roman 3, number 2 Roman 3 and Roman 4, number 3 Roman 3, number 4 Roman 3, Roman 8, Roman 13 and Roman 15. Since the space in the screen is very limited, very little space is there to write, so I only put the number of the question of this exercise. I think easily you can find the question from this textbook. So viewer, today I only select these two problems from this exercise. I think you can manage the remaining problem from exercise 5.1. So I conclude my class. In the next video, I'll try to solve a few problems from the exercise 5.2. Thank you.